Jeff Loughridge is the co-founder and CTO of Konekti Systems. Jeff and his team have a deep focus on building and operationalizing secure networking to the cloud, inside the cloud, and leveraging DevOps and infrastructure as code to assist clients in modernizing their operations. Prior to founding Konekti, Jeff advised Tier 1 ISPs on the design and implementation of large-scale IP MPLS networks. How's it going?
Hey, William. Great to be here. Things are going pretty well.
So you're in the around the DC area, right? How's the weather?
It's pretty nice today. It was cold over the weekend and rainy. Today in Leesburg, Virginia is nice and sunny. Still a little bit on the cold side.
Yeah, definitely cold here. I think it was below 30 this morning when I took my kid to school. Like frost over everything. I had to de-thaw the car off. It was pretty cold.
Yeah, winter is not my favorite.
Likewise. So I guess we can sort of kick this off. So for the audience, I had the opportunity to meet Jeff at an event called the Network Automation Forum. We were on the same panel together, and I thought the talk that he gave was really interesting, and I wanted to bring him on and talk about it. But before we do that, we're probably going to hit some 3-letter acronyms. Maybe more than 2 or 3. So I wanted to just go over what they mean before we get into the show. So I'm going to refer to the Network Automation Forum. We're going to talk about it a lot as NAF, N-A-F. And then we're probably going to talk a bit about wide area networks, or WAN, W-A-N. And I guess most of my audience is going to be predominantly cloud. So a wide area network is essentially just, if you think about your home office or you go into the office, you're in a single building and you're connecting things in that building. That's a local area network. But imagine like a wide area network is a big network that connects smaller networks or computers over long distances. It's like a highway, a system that links cities and towns. And like just as highways allow cars and traffic to travel between different places, a WAN lets data and information travel between, different computers or networks that are, far apart. And then I think the last one that we'll probably refer to quite a bit is CSP, which is Cloud Service Provider. And the context for that in this conversation is going to be the public cloud. So Amazon Web Services, Microsoft Azure, and Google Cloud Platform. So those are, what we would consider CSPs. So let's get going. So first off, Jeff, what does so you're co-founder of Konekti Systems. What are you all doing at Konekti these days?
Sure. Konekti Systems is a small consulting company. We specialize in helping clients build secure cloud infrastructure. A lot of our work does involve a networking component because both of our backgrounds is in large-scale IP networking. Our projects take the form typically of either design work, let's say designing a centralized internet egress with inspection, potentially, or a VPC audit, implementing Terraform for a design. Those are example projects for us.
Awesome. And so to kind of go back to the NAF, Network Automation Forum, you gave a talk about network as a service. And, how there's kind of this thing going on. There's a big shift from, the older way of doing things, telecom, traditional WAN services, provided by like ISPs maybe, to, increasingly popular CSP WAN services. So first off, can you define what you mean by traditional ISP WAN services? What does that mean?
Sure. Back when I started my career in networking in the mid-90s, those traditional WAN technologies were things like TDM-based private line, T1, T3, ATM, frame relay. That slowly gave way in sort of the late 90s, early 2000s to layer 2 VPN services, layer 3 VPN services. I would call those collectively as legacy offerings from either telcos or ISPs.
Okay, that makes sense. And you sort of make the case that the traditional WAN services, the way that they, really have been for all of time, are not really friendly to the folks that want to apply some automation to that piece of the infrastructure. Why is that?
There are several reasons. Traditional WAN services are inherently bound to physical constructs, circuits, big iron. When that's the case, it's very difficult to automate. In addition, those interactions that you have as an enterprise with the telco or ISP are very manual. There's not an API to deal with some of the telcos or ISPs. The turnaround is often very slow, measured in weeks or even months. And then when you use those services to build out your enterprise WAN, there's often a per device configuration. You're configuring OSPF on maybe 1,000 branch routers. You're doing something on a per router, per switch, per firewall basis, instead of buying this fully managed WAN from some entity.
Gotcha. And when you say like not a lot of APIs or limited APIs, the alternative to that is just like screen scraping type utilities, right?
Yeah, back in the 90s, we used like expect, Perl. You were having the software go into a router or switch and scrape the screen, look for certain text-based patterns, and then react. So if there was an upgrade to the next version of Cisco iOS software, that could potentially break those. It was very messy, not at all a good spot.
Gotcha. And another fact is none of that was ever probably, if it was built out, it wasn't, held in source control usually, or version control. So the cloud service providers, they came into the kitchen and they took that table and they flipped it over and changed things up a little bit. So, what is it with cloud service providers, their WAN, that's better suited for automation in general?
Sure. If you look at the Googles, the Amazons, the Microsofts of the world, they've invested so much money in their infrastructure. I'm going to guess that they decided that how can they leverage that infrastructure for more than just the cloud resources themselves. And I believe that they thought of these type of services where they can offer services to enterprise to leverage those investments, those time they've put into their backbones as external services that enterprises can buy to piece together their WAN.
Yeah, I agree there. Yeah, the CapEx spend across, I think, the big three cloud providers, I don't have the numbers in front of me, but like from 2020 and beyond even, it's just astronomical. And
definitely.
Yeah, it turns out the more money that you put into something when you have the right engineering behind it, it's going to be pretty robust and it's going to have some pretty good scale. So at a high level, what might a large enterprise or any enterprise, I guess, gain by rethinking and really putting a lot of trust with their WAN to a CSP, or a product built, on the cloud service providers for that matter?
There's a number of benefits. I mentioned leveraging those investments, flexibility, implementation speed, uptime, availability. It's really tough to outperform the hyperscalers in those respects. So those are all benefits in addition to the automation piece that you mentioned.
And so in your talk, you kind of walk through the evolution. There's a shift of like more and more networking to the CSPs, starting with the initial offerings of basically like building your own design with appliances in the cloud, which is kind of what we've always done. Like in the past, whether it was a physical network or a virtual network, we've said, hey, we're going to put a physical router or some physical box, usually two, at each network that we want to connect, two for high availability, usually in an active standby configuration of sorts. And then we configure those, and then they talk back to some, maybe your data center, a hub of some sort. Can you walk through that sort of evolution of how this has changed going into the cloud?
Sure. I mentioned 3 iterations in my talk. The initial one, as you just said, was we'll host your appliances. Typically, either SD-WAN appliances, could be firewall, could be some kind of network device like a switch or router. The the CSP would just host that, and you would build something on top of that, like a SD-WAN implementation. You saw things like AWS enhancing Transit Gateway to support GRE connections to these SD-WAN appliances. That was the first phase. The second was when they started to use sort of the native constructs like Transit Gateway, and that allowed enterprises to roll their own WAN. You were still rolling your own, but you're using more native cloud constructs. Still at that time, it was very regional. If you bought a private line to one of the providers, it was typically just for use for that one region. There was no notion of using a private line that you bought maybe on the East Coast to your West Coast cloud resources. The third iteration is when we really saw things like global connectivity for a single connection. You could reach either cloud or your resources globally. You saw enhancements to services, like, for example, AWS SiteLink, where you could use the Direct Connect gateway to directly connect, let's say, to data centers. There was no real cloud hop there, just a layer 3 hop to get to your other resources. In that third iteration, you also saw additional abstractions, like, for example, AWS Cloud WAN, where they built that on top of Transit Gateway. So no longer are you managing individual transit gateways. You are managing this Cloud WAN where you can describe the connectivity you need in a JSON document.
That sounds much more developer friendly to me.
It definitely is.
How does this new cloudified WAN lend itself to developers or just network folks that want to be more on the, practical automation side?
Sure. To be fair to traditional WAN automation, you're not really comparing like for like here. Because in the cloud, things are sort of inherently virtual. It is much more easy to automate. It's easy to have an API, to have a Terraform provider. You can use those things to build out your WAN. You're no longer configuring 1,000 devices. You're using an API to instantiate like what I call an enterprise WAN fabric, to borrow a term from the data centers, because you get this extreme flexibility in using these cloud offerings to build out your network.
Yeah, 100%. I think one big distinction there too is just if you look up the sort of the difference between like runtime and build time automate, or just immutable and mutable. So if you have a physical construct, it's always going to be mutable because you have to rack and stack and cable and deploy that sucker. And then after the fact, you connect to it, make changes, and then kind of over its life cycle, it's still running, usually in production, and you're making changes in a change window. Whereas when you get to like more of the immutable side, obviously you can shift more to the build pipeline and like procure artifacts and, with source control and CI/CD and, deploy that artifact. So it's configured at build time, like before it even gets deployed. And then you just deploy the artifact. So just, completely different methodology from top to bottom.
Yeah, I think that immutable point that you just made is a really good one. It's a good way of thinking about it.
You joked in your NAF talk about kind of going back in time to the 90s and suggesting to your mate over in the other cube that your enterprise's WAN should be, hey, why can't we check this into version control? So it's 2023. Can we actually do that now? Is that a reality?
Yeah, we can. We can actually check into GitHub or GitLab. It's a much easier thing now, because now you express your WAN in Terraform in a JSON policy. I think even more advanced though than doing a git and then a revert to back out of something, you might be able to create a CI/CD pipeline that integrates testing of operational state, such that you don't get to a point where you have to do a git revert, even though that functionality will be there when you're using version control.
Awesome. And, networking is just kind of always lagged behind other disciplines as far as the automation and things are concerned. And there's a few reasons for that we don't, I need to go into detail here, but do these newfangled additions to the toolkit sort of give network engineers an opportunity to sit at the DevOps table, at least for wide area network and other virtualized networks.
Yeah, I think you're right that networking definitely has a bad rep. I'm sure the developers in your audience will probably think about networking as having to open a ServiceNow ticket to get a new VLAN or an ACL update and then waiting 3 weeks to get that. I think there's a reputation that network engineers are the folks who slow down the developers. I think that with these new abilities that we have, at least on the WAN side, we can bring networking up to par with the DevOps organizations. I think perhaps other parts of networking, like inside the data center, you still have some of those same difficulties. At the NAF, they talked a lot about lack of standardization. You have a Cisco or Juniper or Fortinet. There's no common layer to communicate with all those devices. That won't change.
Right. So, as you said, we can kind of check our wide area network straight into Git. And I know one big, when I worked in the enterprise, every change I was going to do in production, when I attached it to that change order, I also had to attach back out steps. So if things go south and, we're sweating bullets and we have 1 minute left in the change and things are broken, we got to roll that sucker back. So does that look the same with this newer technology and and kind of like transitioning that old way of like, okay, we have these service operating procedures with these network engineers in the data center and they like have 100 Word documents and lots of text files and doing everything that way. What does that look like now?
I think the old way, where you typically had like a Word document with this giant description of the backout steps, where you copy and pasted into a router. I don't know if you recall, but usually you'd hit like special characters in Word that you'd paste in the router would choke. Those were not the good old days. I think now you can really get to that point where you can either do a git revert to the previous known good operational state, or get to a point where you can do pre-commit testing such that you don't get to the point where you have to back out. That may be a little bit on the advanced side, but that would be the end state that I would advise enterprises to be targeting.
Right. So yeah, good point. One thing that I think of sometimes is, some of the network engineers I've worked with in the past anyway, they're a little salty, and for good reason, because the network always gets blamed first, and it's something that, hey, it's the network's problem until you can prove otherwise. And then on top of that, you don't get a lot of leeway with how you can execute changes and do things. It's a tough job. And as I look at some of these newer WAN services, like Azure has virtual WAN and AWS Transit Gateway, like all these different technologies, it seems as though enterprises are still going to need some solid networking expertise, but maybe just augmented. So I guess we're not getting rid of any of those salty network engineers that have these deep skill sets in the data center, or what do you think?
No, that will never happen. I think I am admittedly biased, but I feel that we'll always need engineers with a firm understanding of networking fundamentals, first principles. I think organizations should consider how going forward they can use their network engineers to help the business drive towards a more frictionless deployment of applications. There's just certain things like BGP that you can never really abstract away. So no, we'll always need network engineers. Their jobs may look a little bit different than they did, say, in the 90s or early 2000s, but we'll always need them.
I agree 100%. And I think, honestly, investing in more network talent would be a wise move. I mean, I don't have any data to support this. It's just my opinion. But I think that if you were to actually hire more skilled network folks and then find a way to hold on to them, because folks tend to jump around a lot these days. Having that sort of team that can see through like the transformation of your network and then keeping things, steady state, integrating new things as they come along and just, zooming out and having a better handle on the network as a whole. And yeah, you're right. The tools and workflows are going to change. But hey, you know, BGP's been around for how long? TCP IP.
93, yeah.
Yeah, all these things are still the core of what is actually happening under the hood. And the tools and processes, like some of the stuff I've had to do to put together some complicated like CLI based configs and, put them on a device. That's pretty daggone complicated. If you think, Terraform's complicated, like doing a lot of what we've done over the years in the CLI, I think is even more complicated, to be honest. So
Yeah.
as long as you're a network engineer and you are not opposed to taking that move to learn some of these new tools, I think it's kind of an easy transition, to be honest. You just can't do it all at once. It's a little slow and a little progressive.
Yeah, I agree with that.
So let's talk about the good, the bad, maybe the ugly in terms of the business and, the engineers, the business employees. Would you consider replacing or augmenting the WAN, with a CSP backbone, like a net positive? Like, is that something that, large enterprises should be evaluating?
100% yes. I think there is a shifting of the data center of gravity. You've heard that moving from data center to cloud. As that happens, I feel like it's almost a no-brainer that you'd want to minimally evaluate those new CSP WAN offerings to see if they are a good fit for your organization.
Right. And we kind of talked about, engineering jobs. I don't think engineering jobs are going to be in jeopardy. I think there's going to be opportunity for more upskill and advancement. But what about multi-cloud? I would say if you're going to keep going with like completely cloud native products in this scenario, the CSPs definitely have motivations to keep you in their ecosystem. Is there a play here for like a network product to use like across all the clouds?
There is. Before I answer that question, may I just briefly jump back to the skills piece?
Yeah, absolutely.
I think that good organizations will train their folks, show them how to advance their skills to get to where they are. I do think, though, that if you look at some large enterprises that, let's say, have teams of like 50 people just to manage their extranet, their WAN piece, setting up IPsec tunnels to partners. As those services shift to cloud, I'm not sure you still need those large teams, but I mean, definitely good organizations will train those folks, repurpose them to other parts. I do think, though, that on the WAN side, you may not need as many folks doing certain jobs. All right, so let's shift to your question on multi-cloud. I think there's definitely an opportunity for vendors here, for our clients who are interested in multi-cloud. And for some large enterprises, they absolutely need it. I'd say for startups, you probably don't want to get involved there, but for large enterprises, you do need multi-cloud. Our clients in that space want a consistent experience across clouds. That's the number one thing that they mention. So I do think there's a play for vendors like Alkira to be able to enable networking both within the cloud and cross cloud in a way that gives enterprises the ability to sort of have the same feel for Azure or Google or Amazon. Definitely a play.
What about, so I'd say like one big challenge I hear about a lot is observability, essentially getting the right visibility you need. And just, you get it in different ways across these cloud providers. How do you handle the visibility aspect or the reliability or, all these things across so many different areas?
Would say the observability metrics piece is probably the worst aspect of these CSP WAN offerings. You get very little. It is the proverbial black box. I believe the vendors have a long way to go to improve here. Many of our enterprise clients complain about this. They don't know what's going on. You can't build more advanced like reactive automation into things if you don't have a feel for what's going on in that cloud. It's a major negative point in these offerings.
Right. Yeah. Observability's always been, it's always been tough. But I mean, back in the area we sort of came from, you had your SNMP strings, you had your MIBs, you had like tools that you plug these things into, and it kind of just gave you some alarms like, okay, this neighbor's flapping or this thing is happening. You need to action it.
Yeah, and I
And
think SNMP is on my list of least favorite networking protocols, along with IPsec and others. I think SNMP was just a not at the time it was an okay way of doing things, that just not the way that I like to work.
yeah. So why don't you like IPsec? Let's get it all out here.
Uh,
It's been around a while, that's for sure.
Yeah, it has. There are a lot of reasons. It's in my opinion, it's a terrible protocol in terms of, lines of code. There's a million lines of code. If you compare to newer technologies like VXLAN or WireGuard, it's just really bad. Interoperability. Have you ever tried to get Fortinet to work with like a Cisco ASA? I feel like anytime there's a turn up for, like, let's say partner connectivity, there's this call where we all sit around and try to figure out why the interop is not working the way it should. There's a million ciphers. With WireGuard, there's a public key and a private key. Turn up a tunnel. There's Linux support in the kernel. It's just, I don't know why we still use these older things. I mean, I know the answer. It's that they're supported in every appliance, every physical networking piece of gear. But other than that, I think we need to move away.
It's funny you mentioned WireGuard, because I was just looking at the source code like a few days ago, and it's so small.
It is.
If you compare it to like OpenVPN or some of these other solutions out there, it's like, whoa, this is just microscopic in comparison. The code base is.
Yeah, I think when you have a small code base, it's easy to analyze that for correctness. How do you do that for IPsec? How do you do that for OpenVPN? You're looking at this giant code base. I'm not even sure that's possible, even with AI.
Yeah, I feel you. So it's funny. I tried to automate this. I worked for a business that had lots of B2B style action happening, and kind of just exactly what you said. We would get on a stand-up call because we'd get a form, we'd set it up on our side. Phase one, we just couldn't get anything going. And then, like, okay, the other side, it's like a lot of times there'd be like some open source firewall that we'd never even heard of. That's like the other side of the connection. So we'd have to sit and troubleshoot and go through everything line by line. And I don't think I ever had one just work.
Yes. I think I've been on 1,000 calls like the one you just described. I don't like it.
Yeah. I mean, if you own both sides of the IPsec, and you can, there's a lot of opportunity to automate it then, but when you don't own both sides, yeah, it's a little tough.
Yeah.
Yeah. So having this WAN connectivity that is essentially ephemeral, and gets provisioned on demand with infrastructure as code, this sounds like a win for disaster recovery, a topic that everybody loves to talk about but hates to get right. And disaster recovery is something that historically it's just been hard for everyone, especially on the network side. Can you explain how this transition to the CSPs impacts or enhances, your recovery from like US East 1 tanked, we have another DR region. So how does that impact?
Sure. The developers in your audience may not be able to understand with networking how difficult this was previously. If you were born in the cloud developer, you've been able to completely stand up, let's say a new region upon disaster immediately since the early days of cloud, since VPC was first launched on AWS. But on the networking side, you didn't have anything really like that. With these new offerings, not only can you upon failure, create cloud resources in a new region, you can also swing over your enterprise WAN fabric, your data center connectivity, your branch connectivity to this new region. Now that things aren't kind of tied to a single region, they're more global in nature. The ability to swing a network fabric over there is pretty impressive. If you've worked in networking, I think you'd be able to see that maybe a little more so than a developer.
Right. Yeah, completely agree. It's a different world with even
Very
like
much.
HA and high availability. So the way we used to think about high availability, we're thinking about, okay, we deployed 2 boxes at some branch office and we use something like maybe some AS path prepend. So when the first provider tanks, you have an alternate provider, and that that prepend handles your failover. And there's a lot of different tweaks and a lot of different methods. Like I remember this IPSLA, like doing different things to try to make the experience better. And it's hard. So yeah, high availability in the cloud is, availability zones, and you don't really have to think too much about it. So when I know the service, like I work for Alkira and we do high availability by default. So the customer doesn't even have to think about it. But if you're going in cloud native and you're dealing with it, at least the high availability part isn't terrible compared to how it used to be. And high availability means actually instead of 2 different devices, you have 2 different data centers completely that are geographically somewhat separated in the same region. So yeah, very cool.
Yeah, definitely.
So last thing I just kind of wanted to touch on, cost is, cost and capacity planning are such a big part of rolling out like a new type of technology, or like really changing the way your enterprise does things. So historically in networking, we're very heavy with dealing with providers and circuits. And, one area I remember all too clearly was I worked for an org one time that wanted to do protected circuits everywhere. And these suckers were pretty expensive. And, I always got to thinking, like, is it worth spending more when you can't even audit the service provider network? You can't get eyes on to what's actually happening in there. How do you know that, all these things are working in your favor? Why not just buy, double the amount of circuits and get unprotected circuits that are provider diverse and run SD-WAN over them or something? And, with these circuits too, like if you're doing MPLS or a lot of these, you're working through a provider, you're signing usually some, a contract for some extended amount of time. And then you have to wait a long time to get everything, sort of connected. And, that is, not even counting like all the hardware internally that you have to build out, all the engineering and, operations that go into your router, your network design, your engineering within your own network. How does, the shifting to the CSP side of the house make this any better?
I want to touch on your comments on protected circuits first, since that's always been something that I've never liked in networking, whether that's protection using SONET or MPLS. I feel like anytime there's a protection that you don't test regularly, it's going to fail and it's not going to work when things fail. Active is really the way to go. I think you can see, if you've ever listened to the hyperscalers describe their infrastructure, it's almost exclusively active. There's no protection where they don't test. I would never really like that. Active is really the way to go. I think as things shift over to the CSPs, I mentioned that hyperscalers are almost always on the lower layers, an active type setup. You no longer really, as an enterprise, need to be thinking about, oh, I need to build out this complex protection scheme, because when you outsource your WAN fabric to the CSPs, you are paying a lot more for it, but you're getting the benefit of them having to worry about those things that you used to have to think about to keep your networking up and going.
Yeah, I'm really glad to find somebody that agrees with me on the protected circuits thing.
That's you can't disagree with it on that point, I think. I don't know.
I know. To me, it just seems like common sense, but you'd be surprised. Like I've worked at places where it's just standard. Like it's in writing. This is what we do. We don't do it any other way.
I've always asked those folks, how many times do you test that? And they'll almost always say, oh, yes, we do test it. And I'll say, well, let's do it. Let's test it. Oh, well, no, we have to have a window. And I
Yeah,
wouldn't take that approach.
all the good stuff. Well, anyway, this has been a really good conversation. One that I think it's really an emerging movement, and we're going to see a lot more from it, in the near future. And I'm already seeing a lot of it now. Yeah, so thank you for coming on and talking about it. Where you have anything left? First of all, you have anything left to tell the audience, and then where can they find you online if they would so wish?
First off, thanks for having me on. It's been a pleasure. As far as parting thoughts, I would say if you are an enterprise architect, go out and evaluate these technologies, get some hands-on experience. It's hard for me to be able to really articulate the benefits that these technologies can offer to you. Do a proof of concept. Get some hands-on experience. Set up Terraform so that you roll out this enterprise WAN fabric. That hands-on experience really goes a long way. You asked about finding me online. Email is great. Jeff L at konekti.us. LinkedIn. I'm on Twitter, although I don't really use it all that much. Those are all ways that you can reach me.
Awesome. I'll grab your social tags and put them in the show notes. All right.
Thanks,
Thank you
William.
very much, Jeff.
All right. Thank you.